record and share with them when they get on board.
Okay, we'll do that.
Otherwise, Fatma will be here in no time.
Probably. Okay, guys, right, let's go. So, Genesis and Tumaini, welcome and good afternoon, and well done for being here. Very good. I have been asked to do some more work with titration calculations. And it may be that I went a little bit too quickly for some of you last time. So I want to make sure that the triangle up here makes sense and we can use it. So we're going to start with some really simple calculations using this triangle. So I'm just going to remind you firstly of what the triangle was. Really simple. We'll do 6, no, maybe 5 little calculations and you can have a go. Okay, so they will be simple, but I just want to remind you of it. Firstly, so Silver Spring may be here. Okay, so first things first. The triangle is only for solutions, this one. I'll be showing you something in a little bit to do with solutions, but basically, good afternoon, Fatma. So in this triangle, it relates to 3 quantities which we have. Moles is at the top, concentration is here, and volume in liters, which means we normally divide it by 1,000, okay? So what we're going to do is we're just going to make sure that we can use that to relate these quantities, okay? So all we do is when we want to use one, we just cover it up. So if I want to find moles, I cover up the moles. I hope this is big enough for you. Let's get a little bit closer. So if I want to use moles, moles equals concentration times volume over 1,000, okay? If I want to find concentration is equal to moles over volume over 1,000, okay? The reason we do this is to turn milliliters into liters. This is very important, okay? It's very important that we realize that. So a simple question. So I'm just going to ask you to do a few simple questions and hopefully you will become familiar with this because it's very, very important. So fairly typical in a titration, I have 25.0 mils of a concentration, let us say 0.25 moles per liter. How many moles is this? So this is the first question. Okay, first question, just have a go. The idea is this, and I want to just point out something because Genesis were really, really good last time in hanging on for ages afterwards to do more calculations. I want you to recognize that the units tell you whether it's concentration or volume. So, mils, this is a volume. Mole per liter, this is a concentration. So if I look at this, this means I have the volume here, and I have the concentration here, so I can find the moles. So in my first example here, straightforward, I'm just getting rid of this. So if I want moles, moles equals concentration times volume over 1,000, okay? So, if you want to do this yourself, just do it and don't look at me. If you're not sure, just watch this for a minute. So I look in this calculation and I find the concentration. The concentration is always moles per liter. Here it is. So my concentration here, that is concentration. Always recognize mils volume, moles per liter concentration. So this is 0.25 times the volume, mils, 25 over 1,000. And that will give me a number, and the number will be 25, 25, 6, 25 point. You tell me. Is that Ezekiel just putting his head slightly in?
Genesis has a small challenge with the view. They're trying to adjust. They saying the screen is you're looking like you're very far.
Oh, okay. I'll make everything a bit bigger, yeah?
Okay.
I hear for Genesis the screen is a bit small. Let us just try something. Let me just try something, and then we will come back to me in just a moment. Hang on, just a moment. Hang on. Sophia?
Yes, please.
Can you see a lot of stuff which says addition polymerization at the top?
Yes.
Great. Okay, forget that.
Very, very clear.
Okay, right. Let's see if we can use this.
Huge.
Okay, so my triangle, oops, hello. Oh, no. Oh, I just lost you completely. Oh, there we are. Try again. Oh, no, come on. Oh, no, it's not letting me do it. I'm going to have to stop sharing just for a minute, just see if we can do it again. Ah, la, la, la. Come on, pick up. So we've been having problems with Zoom today here. Ah. No, it's not letting me. Oh, I'll just have to write it big on the board. Sorry, guys. Sorry. I thought I was going to be able to use a white pen. I'll just write it bigger on the board. Sorry. Shame. So. I'll just write everything bigger, guys. So my question is, how many moles do I have if it is 25.0 mils of, and then this is mils, so that's the volume, of 0.25 moles per liter. So how many moles is that? I hope you can see that. I hope that's a bit easier to see. Sophia, are you hearing that? Okay to see? So I want moles. My moles equals concentration times volume over 1,000. Okay? I have to always remember these may be the other way round. It doesn't make any difference. I just have to spot which is which. Mils is volume. Okay? So this is here. And this moles per liter, this is concentration. So my moles equals concentration 0.25 here, concentration. You must get them the right way round. 0.25 times the volume, 25, over 1,000. Okay? So that equals that. What is the answer? Can anybody tell me the answer, please? .0625? Is it 0.0625? .0625? Ah, 0.00. Is correct. Okay, 0.00625. If you got 0.00625, good. Let's try another one. Okay, so we're going to try another one. This is going to be different. So again, you are going to be asked for the moles. In titration calculation, very, very common to be given volume, concentration, and asked for moles. We will see a proper calculation later. Okay, so I'm going to rub this out. It is recorded anyway if you missed it. So here is another one. How many moles in, and I'm just going to use 150 mils of, and I'm going to use a different concentration, 2 moles per liter. Okay? Have a go yourself here. I hope you can see that now. I'll try and make it a bit bigger. Here it is. How many moles in 150 mil, 150 mil of 2 mole per liter? Okay, just have a go and then we'll see if somebody can tell me the answer. Wow, that's fast. Good. Well done. Somebody in Silver Spring is really fast. Yes. I can do chemistry. Okay, anybody in Genesis? Anybody in Genesis want to tell me the answer? Somebody in Tumaini? Silver Spring wins this one, gets gold medal. Somebody in Genesis, somebody in Tumaini? Show me.
0.3 moles.
0.3 moles.
Yes. Yes. Good. when you are doing a calculation, always write out the method. So tell the examiner, yes, I see, thank you. Concentration times volume over 1,000 equals. Always make sure it's in the right order. Up a bit. That's the last one, yes? Yes, good. Okay, so concentration moles per litre. This is 2 times 150 over 1,000 equals 0.3 moles. Okay. All right, good. Excellent. Let's try another one now. Let's try a different calculation, a different type of calculation. I hope everybody is getting the idea. Each time we just use the triangle to tell us which one, to find the one that we're missing, okay? So I'm going to give you a different one now. Everybody got this? Is this okay? Yeah? Okay? Excellent. Okay, here we go. What is the concentration if I dissolve? In the questions, they put more and more words in to make it more complicated. If I dissolve 5 moles of HCl in 10 liters. Now, we have to be a little bit careful with this one because here they have given you 10 liters. If you remember from the triangle says moles here, concentration here, and volume over 1,000 here. This is only volume over 1,000 to turn it into liters. It is just volume if it is already in liters. Okay? So volume, this volume down here must be in liters. So if the question already tells you in liters, you don't divide by 1,000. Okay? So this down here is 10, not over 1,000. Okay? So this volume down here must be in liters. So you don't divide by 1,000 if it is already in liters. Okay. Have a go. Is that 500? Ah, no. This here, this, we don't divide by 1,000. Okay? This is the point. Because this is 10 liters, the volume here must be in liters. Okay? So we learn the triangle which says volume over 1,000. Over 1,000, to turn it into liters, because most volumes are in milliliter. So to turn milliliters into liters, divide by 1,000. But if, and this is why I'm giving you this one question, most of the time you find it volume is in milliliters, but here it's in liters. So if it is here, stays here as 10, not divide by 1,000. Yes, Silver Spring gets it. Okay, well done. Yes, Silver Spring gets it. He's trying to get all the gold medals. So in this case, concentration, I want this. I want concentration. Yes, it is. I want concentration. Okay. So I divide moles by volume. Moles by volume. Okay. So I say concentration equals moles over volume. Like I said, if the volume is in mils, we must divide by 1,000. Okay? If it is in mils. If it's in liters, we keep it. Okay? So this equals my moles, here. 5 over, here. 10. And this is 0.5, and it will be 0.5 moles per liter. Most of the time, you don't have to worry about the units, but it's worth noting them. Okay, is this okay? Genesis, is this okay? Tumaini, is this okay? Okay, so here's one for you. Okay, here's a more difficult one for you. Okay, so a student dissolves 0.61 moles of NaOH, sodium hydroxide, in 18.5 milliliters of water. What is the concentration? Okay, so you start concentration equals and go on. And let us see if you can work out. Okay? I hope that's big enough. I'll come to the question from Silver Springs about the symbols. Okay, we'll talk about symbols in just a minute. Check your percentages. The 1,000 and 18.5 other way up. 18.5 over 1,000. I can just about see that. 2 people have got it right already. One was written the wrong way up. Yes. Well done, Michael, whoever that is there. Is that Ada? I can't read the name properly. Yes, Ada. Very, very good. That's very good. Well done. There is somebody from Silver Spring. Okay, we don't want to waste too much time doing it, so let's have a quick look. The concentration is moles over volume over 1,000, so that can come up here, equals, I've got 0.61 over 18.5 over 1,000, bring this up here, and the answer comes out, and I've had 3 people say it so far, 32.97. Who got 32.97? Who got 32.97? Put a thumb up if you got right. Tumaini, come on, you got it right. Yes, good. Good. Silver Spring, yes? Good, excellent. Okay, right. So if we can do those, then we can move on to proper titration calculations. So now we're going to try one, okay? All right. I had a question from Silver Spring. Which was about the units. Could whoever was saying about the units, could you write a little bit more? Were you talking about moles per liter, or were you talking about the chemical units? If you write a little bit more in the chat pane, please. Okay, let's see if we can do a proper calculation, and then we'll move to an examination type of calculation. So, 25.0 mils of NaOH of unknown concentration was titrated against 0.2 moles per liter H2SO4. Okay, hope you can see that. So that is 25 mils of NaOH titrated against 0.2 mole per cubic liter, mole per liter H2SO4. The results are shown. Now, this is how they often show you a calculation So you often get a table of information. These are the titrations across the top, the volumes which were seen in the practical. So what they often say is, I do it 4 times. And they ask you, firstly, to find an average, but I'll show you what goes wrong with this and what is right. Okay. So the first, what they often do is they put, this is the final volume, and this is the starting or initial volume, okay? So this is the total. So let's say we have, it started at 0 at the top of the burette and it went down to 25. In the second one, we don't bother filling it up again, and it goes, oh yes, 25 is the start volume, and the end is 49.5, okay? Then they fill it up again, so it starts here, and they go, it took 23.6 here, and then they start at 23.6, and it goes to 58.3. Let me just check those. Okay, so here are some volumes, okay? What you have to do first is to work out what the total volume is here, okay? It's easy here. So this is what they said at the end of the titration, and this was the start, okay? This is quite a common question. So you go, okay, 49.5 minus 25, 23.60 minus 0, 48.2 minus 23.6 equals, okay? So just do that first. Just look and see what numbers we get. What numbers do we get here? This is quite a common question. Do you see what we're doing? We're just taking this one. This is start. This is where we started. This is the final. So we just work this out. So this is going to be 24.5, 23.6. Okay? Everybody see that? Now, the important thing is this. If you are given numbers like this, first, you do not use this one. You don't use this one because there are no decimals. It is not accurate. This was an estimation at the beginning. We don't use it. We look at these and we are looking for two which are very close together. If all three are close together, fine. But this one here is not good. No good. These two very close together, this one, no good. This one too far. So the student made a mistake. Okay, this is what is happening. The student makes a mistake. This one here is no good. So you don't use it. It's important you know this. When you do the titration, maybe you do it only 3 times. If all 3 results very close together, use all 3. If one of them is wrong, get rid. Do not use it. Everybody understand that? Is that okay? So you just, no, don't understand? Silver Spring, do you understand? Don't understand. Okay. When we do titration, we do it several times, many times sometimes, and what we do is we have to pick the best results. If we get a result which is not very good, then we get rid of it. We have to throw it away. So in my calculation here, what I found was my first one here was just a rough, just estimate. Yeah, so we never use the ones which we just estimate. It's just approximation, no good. This second one, total was 24.5. Third one, 23.6. Fourth one, 24.6. These two are very similar, very close together. This one, not so good. They have to be very close together, okay, the numbers. So I look at these 3 and I go, hey, are they all the same? Are 2 of them close? So I find these 2 are close. I will use these 2. They are okay. This one is too far away, 23.6. It's too far away, okay? So if it's too far away, I get rid of it. So I only use these two. That is a really important skill. If you do paper 3, if you do a practical paper 3, if you do the practical yourself, you will find that you will get some which are very close together, and sometimes you make a small mistake. Not a problem making a mistake, but you just ignore that number, okay? We just miss it out. So in this one, I use this one. Yes, yes, no. Okay? All right. So I'm going to use these two numbers, 24.5, 24.6. They are very close together. So the first thing they say is work out, thank you. The first thing they say is work out the mean, okay? So now we will go on with the question. So we know, so the question we have to do is, number 1, work out or calculate the mean volume. Okay, that's the first thing you would have to do, work out the mean volume of H2SO4. That's the first thing. If you are writing this down, leave a gap here so we can write the answer, okay? Number 2, calculate the moles of H2SO4. Okay? So that's the second part of this. The third part is find the moles of NaOH. Okay, so that's nearly the end of the question, but find the moles of the NaOH. So 3 parts so far. There is another part which will come. Okay? Okay. So this one here, part 1, this is easy. This is 24.5 plus 24.6 divided by 2. Yeah, the mean volume. It's just very important that you do it carefully. Yes. Equals 24.55 milliliters. Okay, that's the first bit done. That's easy. So there you have to start by finding the best results, the ones which are close together, and then finding the mean of those 2 or 3. Okay, so these two very close, add them together, divide by 2. The second one now, you can do this because we were doing this at the beginning. So the moles equals, use the triangle, the moles equals what? 24.255. Not quite. So number 2, let's just have a look at this here. Moles equals concentration times volume over 1,000. Okay? So equals that. That's much better. That's much better. So the moles is concentration times this, but it's not, for the person who just showed me that, it's not this, it's not the 25, it's the 24.5. So moles equals concentration times volume. Well, this is the concentration times the volume is this one here. It's the one we just worked out. 24.55 divided by 1,000. Okay? What is most important with these is to see which chemical has which numbers. This is the thing which matters. So moles equals concentration times volume. We are told in the question that H2SO4 concentration is 0.2. So it's the concentration 0.2 times the volume, which we have just done, 24.55 over 1,000. So this number is, somebody in Silver Spring is going to try and show me. Yes. 0.00491. This is moles, so we just write moles here. Okay? So we've done this one. And now we have worked out the moles of H2SO4. So this is number 2. So number 2, it asks for the moles. You have to find the concentration and the volume. Okay, concentration, volume, concentration 0.2, 0.2, that is in the question. It told you this. You have just worked out the volume, volume over 1,000. This is the answer. Now it says, find the moles of NaOH. Now, if you were here last time, you will remember, I hope, that we looked when we were balancing the equation at the number of hydrogens and the number of sodiums. It has to be the same. So if I am balancing this equation, it is going to turn into other chemicals. They don't really matter for this part. I have 2 hydrogens here, so I need 2 sodiums here. So it is 2 NaOH. So 1 H2SO4 reacts with 2 NaOH. So 1 molecule reacts with 2 molecules. Now, this is what I teach my students because some of them find this quite difficult. So I'm trying to find the moles. So I can read this equation in words. I can say 1, because there is no number here, 1 H2SO4 reacts with 2 NaOH. Okay? 1 with 2. So 1 molecule with 2 molecules. So what I tell mine, because many of my students can say that, they can say, oh yes, 1 molecule, 2 molecule. I now just get rid of this. Okay. So 1 mole, 2 moles. Okay. I have this here. This is the moles of sulfuric acid. If 1 reacts with 2, 0.00491 reacts with How do I do that? You see, from the equation, when you have the moles of one of the chemicals, then you look at the equation to find the other moles. That is always true. You always find one of the moles and then look at the equation. So, 1 molecule, 2 molecules, 1 mole, 2 moles, 0.00491. It must be twice as much. Ratio 1 to 2. I can't see your answer. I can just see the calculation. I can't see the end of it. Yes. So this will be this times 2, which is 0.00982 moles. Okay? Yeah, well done. Really good. Very, very good. The people who have just shown me their pictures, very, very good. Really, very good. This is quite difficult. Well done. Good. So now let's have a look at it. So question 1 was you find the volume. So you look at the table with the numbers, you find the ones which are very similar, and you find the mean. Then it said find the moles. Moles equals concentration times volume over 1,000. So I put it in. Simple. Okay. So then the third stage, always the third stage, if you have worked out the moles of one chemical, you then look at the equation. The equation will tell you the next bit. So we said, look at the equation, 1, 2, 1, 2. Okay. So 1 molecule, 2 molecules are 1 mole, 2 moles, 0.00491, 0.00982. Twice as much, just times 2. Easy. You can do that. I know you can do that. The last bit. The last bit is number 4. Find the concentration. Yeah. Sorry, say again. You can't see it or what? Silver Spring? You don't understand this? You don't get this, no? Okay, all right. Genesis, did you understand this? Tumaini, do you understand this? Tumaini? Excellent. Okay, really quickly, Silver Spring. The idea is this. The ratio is the number in front of these two chemicals. There is no number here, so that is 1. 1 to 2. 1 reacts with 2. You have just found this number here. So this number is 1. What is 2? It is this 0.00491 times 2. That's where it comes from. 1 to 2, if it was 1 to 2, 10 to 20, 100, 200, 0.00491, 2 times as many over there. It's on the recording, you will be able to see it. Okay. If you can hang on at the end, I will do it again. So find the concentration of the NaOH. Hi, Kamal. So concentration equals from the triangle concentration at the bottom on the left equals moles over volume over 1,000. Now I have just worked out the moles of the sodium hydroxide. And if you look in the question, it tells you the volume, okay? If you do that, you will find that in the question, it tells you the volume. You find that volume in the question, which we wrote down, and it will make sense. Who's got an answer? Who has an answer? In the question, it said the volume of sodium hydroxide, I think it said was 25 cubic centimeters. So the answer will be, yes, good. Silver Spring, well done. Well done. Anybody at Tumaini? Tumaini, come on, you can win this one. Who has an answer now? We have some good answers in Genesis. I know, come on, Genesis, you can get this. Show me your answer. Just come up with your book and show me it. Show me it. Show the camera your answer. Bring it up. It's in sunshine. I can't see it. Bring it up. Bring it up. Seriously. Come on. Come on, Genesis. Have courage. Let's have a look at it. Oh, I can't see it. Up a little bit, please. Oh, hang on. Let me just pin this. .3928. Yes. Yes, 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 yes. Well done. Very good. Well done. And 0.3928. Excellent. Well done, guys. Okay. Okay, so what we've got now. 0.3928. Yes. Well done, guys. Honestly, really good. Really, really good. Okay. Another one. Dan, you're moving the camera too quickly. Has everybody got it? Show me another one. Yes, Michael, well done. Yes, it might be upside down, but I can still see it. It's right. Yes. Thank you, Michael. Yes. Thank you, Dan. Yes. Excellent. Excellent. Really excellent. Yes, and it's a very smart tie. It's almost as nice as the hat just behind your left shoulder. Yeah, it's a very nice one. Yes. Yes, 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 yes. Oh, damn, they don't want to show you, do they? Okay, okay. So let us just look back at what we have just done. This is important. So that was 0.00982 divided by 25 over 1,000. So we had 25 mils of unknown concentration. I'll just use a better pen. Just look at this, guys. Just look and realize what you have just done, because I think what you have just done is really good. First step, we had to find the mean volume. And we only use the values which are close together and find the mean. Then we worked out the moles of the H2SO4. And then we use the equation to find the moles of NaOH. And then from the moles of NaOH, we find the concentration of NaOH. It is always the same sort of pattern, always, okay? Sometimes they ask for little bits of different, but it's always the same idea. If you have to work out an average volume, you work that out, find the similar ones. Then you work out moles of one of the chemicals. Then you look at the equation. This is tremendously important. Then you look at the equation. The equation will tell you the moles of the other one. Simple ratio. In this one, 1 to 2, 0.00491, twice as much, okay? That's really important that you see that. You work out moles of one, and you will look at the equation to find the moles of the other one. Now, I have sent to you a calculation which is a bit different. I'm now just going to very briefly, because I know you have to go, but I'm going to show you very briefly how it works, okay? Because it is already, for you, 5 o'clock. For me, 2:05. Sometimes the titration is not to do with acid and alkali. Sometimes it's to do with something like potassium permanganate. And it doesn't make any difference which one it is. It doesn't make any difference at all. If you get an equation, better pen. You look at an equation like this and you go, well, I don't know that. I can't use that. It's too complicated. It's really hard. It's really, I don't know who can do this. All you want to do is look at the equation and find the chemicals you want to look at. This is permanganate. And this is iron. And don't worry about writing this down, because if it's this complicated, they will write it for you. It will be in the question. The point is, if I look at this and this, I am only interested in the ratio. So 1, look, the number here, 1, 5. So if you have a calculation like this, we don't worry about the equation, the big complicated equation. We don't worry. We go, all I need to know is 1 and 5. That's all I need to know, because in the calculation, they will tell you, oh, let's say 19.8 mils of this, and this is the volume, and the concentration is 0.007 moles per liter. Don't bother writing, just concentrate. Don't bother writing, just look. Okay, just concentrate, just a moment. This is going to, the question would be, tell me something about the iron. But it starts here. In the question, they give you the volume of the permanganate and the concentration of the permanganate. You know now that from that triangle, I can now work out the moles of permanganate. And it will say in the question, find the moles of permanganate. Okay, I can do that. I know my triangle, moles, concentration, volume over 1,000. So, okay, moles equals concentration, this, times the volume, 19.8 over 1,000. Problem? No. On my calculator, done. Good. Then it says, now tell me how many moles of iron. And all I have to do is to go, look, 1, 5. So whatever this number is, I multiply by 5 to find this one. That's all I have to do. It's not complicated. They always, titration, I think titration, my students find titration calculations scary, okay? They make them go, I don't know, okay? I'm telling you, you can do this. You work out the moles here, then you look at the equation and it says 1, 5. So if it's 5 times bigger, I multiply by 5, okay? That's it. And then you can do other things with those numbers. That is most of the points. Now, I have sent a question to you, and it looks, you don't have to do it, obviously. I'll just show you what it looks like, or I will try to show you what it looks like. Where is it? I hope you can see this. This is a titration calculation, okay? I'm going to give you a number here, okay? I'm going to give you the number here, 19.8, okay? 19.8. So you don't have to work this bit out. I am telling you it will be 19.8, okay? In other words, in that question, I will put it in and it will become 19.8, and then you can do all the rest of it. I promise you'll be able to do it, okay? Next time, I will show you that question. We will start with that question, okay? Any questions? Okay. All right. It's really time to go. If you want to stay, you can stay. Yes, then you can go. Because you've got some unblocking.
I've actually got a problem with my moles.
Oh, yeah, which ones? The ones in your head?
No, the ones at the front of the house.
Oh, really? Well, I reckon a shotgun is the best thing.
No!
So, guys, I'm going to stay for a short while because I'm going to show you some other bits if you want to see them. But if you want to go. If your teachers are happy, your supervisors are happy for you to go, you go. Thank you very much for being here. But if you want to do a little bit more, I will stay here for another 20 minutes. Okay. But if you need to go...
Mark, may I go, please?
Yes, you can, sir. Bye-bye, Mr. Justin Thomas. Yes. Cheers, guys.
Asante teacher Mark.
Silver Spring.
Sophia, you can go as well.
Well worked today, you guys. Well worked. Really worked.
Very, very good. Okay, I'm going to give you an assignment, okay? I'm going to give people an assignment so you can have a look at it, okay? But otherwise, you can go. Bye. Have a lovely day. Go out in the sunshine. Bye, Michael. Tumaini are being very good. Tumaini are very patient. Very, very patient. I'm impressed. Okay, here's the assignment. I'm going to give you an assignment now, okay? Would you like an easy assignment or difficult assignment? Easy? Difficult? Okay, we'll have difficult. Okay. I'll give you a difficult one. Whoops. Okay, I'll give you a difficult one. Here comes a difficult one. It will still be recorded so people can get it later if they want. I will use this one, okay? I will use this one as a starting point. So, right, here we go. A student was asked to find the concentration of some iron solution they titrated 20.0 mils of the solution against permanganate. Their results were 19.8 cubic centimeters, 18.2 cubic centimeters, 19.7, whoops, sorry, mils. Sorry, you use mils, don't you? My apologies, they're the same. Mils and cubic centimeters are the same. Okay? So there's their amounts, okay? Okay, here are the questions. Number one, find the mean volume of permanganate. Number two, if the permanganate was 0.075 moles per liter, find the moles of permanganate. Number three, now find the moles of iron in the solution. And number 4, calculate the concentration of the iron solution. Okay? The equation that you need is this. But there is no need to write it down, because if you remember, all I need is the moles of this one and the moles of this one. Okay? So this is the iron, and this is the permanganate. And it's the ratio. Okay, it's the 1 to 5. Okay. All right. I've just rubbed out Kyoko. Is that an L or an I? Okay. Snell. Teacher Mark. Oh, Tumaini have all gone. Oh dear. They've all had enough. But you, Silver Spring, strong. Well done. Okay. So, are you okay to try that yourself? You okay to try that yourselves? Excellent. Okay. Oh, Tumaini. On your own. You okay? All right, fat man. Excellent. Okay. Thank you very much, guys. It's all recorded. What I will do, because I know Silver Spring missed the beginning, I will try to put it onto YouTube and send you the link. Okay? All right. Take care, guys. Get out in the sunshine. You know, here today, we have a 30-mile-an-hour wind, 7 degrees, and rain. Nice.
Oh, terrible.
Really,
Terrible.
really disgusting.
Fuera.
Right, Sophia, I will stop recording and I will get this done and send it to you, okay? Right, guys?
Asante sana. Have a good afternoon.
Cheers, guys. Bye now. Nice shirt. I like it. I like it. 2 copies of you. Look at 2. I have 2 pictures of you there. That's very lovely. You just love yourself too much, don't you? Eh? Right. See you later, guys.